In this second module, we are going to examine the concept of work and how that is related to energy transfer. When we lift up a hammer and use a force to hit a nail, we are doing work. You may also have discovered that the impact on the nail is greater when we raise the hammer higher. Why is this so? We have learned in earlier lessons that when an object is raised higher, it will gain in gravitational potential energy. By the principle of conservation of energy, energy cannot be created nor destroyed. So this gain in gravitational potential energy must have come from the force we exert in raising the hammer. So when we exert a force, we are doing work, and we are effecting an energy transfer to the hammer. Doing work is a way of transferring energy. So the higher we raise the hammer, the greater the gravitational potential energy. That means the more the energy is transferred to the hammer. That also means the amount of work we are doing is greater. Now, the work done by a force is defined as the product of the force and the distance moved in the direction of the force. For this example, the force exerted to raise the hammer has to overcome the weight of the hammer, which is equals to mg. That is, its mass times the gravitational field strength. If the hammer is raised to a height h, the work done, which is equals to force times distance moved, is equals to mg times the height h. Since work done equals energy transferred, this is also equals to the gravitational potential energy gained by the hammer. To better understand the relationship between gravitational potential energy and work done, we shall now look at another example. Here we have a man exercising by lifting a barbell with weight plates added to the bar. He is providing an upward force to overcome the downward force of gravity on the barbell and the weight plates. The force moves the weights upwards, so the force is doing work. There is an energy transfer as the man loses energy and the barbell and weights gain in stored energy, which we call gravitational potential energy, as they are lifted to a higher position. The work done by the man is therefore the force exerted by the man multiplied by the upward distance or the height h moves by the weights. The force exerted by the man is effectively the total weight of the barbell and weight plates, and that is given by the total mass m multiplied by g, the gravitational field strength. This work done by the man has effected a transfer of energy. Let's call it EP. EP is therefore also equals to mgh, joules. This means that at that lifted position, the barbell and weight plates have stored gravitational potential energy equals to an amount of mgh joules. If the man drops the weights will now be able to drive a stake into the ground and do an amount of work equals to mgh joules. Therefore, the formula of gravitational potential energy is given by EP is equals to mgh, where EP is the gravitational potential energy in joules, m is the mass of the body in kilogram, and h is the height in meters. Now, what if the force that we exert on an object is not to raise the object, but to move it horizontally? Are we doing work? Is there energy transfers? You see, when a man pushes the cart with a force, the cart gains kinetic energy since it is now moving. Hence, there is a transfer of energy. In other words, when a man exerts the force to push the cart by a distance, he is doing work by transferring energy to the cart. The cart gains kinetic energy due to the work done by the force. For force to do work, there must be movement in the direction of the force. The work done by a force is defined as the product of the force and the distance moved in the direction of the force. So for this boy, he is using a lot of strength to carry a heavy box, but he is not moving the box. In physics, we say that there is no work done. Note that even if he starts to walk, but as long as the force that he exerts to carry the box does not move the box by any distance upwards or sideways, it is still considered as no work done. For a force to do work, there must be distance moved in the direction of force. In this case, when the force is exerted on the box, there is work done because there is a transfer of energy to the box. The box gains kinetic energy and starts to move. The kinetic energy gained by an object is given by the following formula: Ek equals to half mv squared, where Ek is equals to the kinetic energy in joules, m is the mass of the object in kilogram, and v is the speed of the object in meters per second. Take note that this gain in kinetic energy by an object is equals to the work done by a force exerted to move the object by a distance of s. Hence, work done is equals to force times distance s is also equals to half mv squared. For both energy and work, the correct SI unit is the joules, since work done is equals to energy transferred. From the equation of work done, 1 joule is defined as the amount of work done when a force of 1 Newton moves a distance of 1 meter in the direction of the force. In summary, work done by a force is equals to the force times the distance moved in the direction of the force. Hence, doing work is a way of transferring energy. The gain in gravitational potential energy by an object that is raised by a height h is given by EP is equals to mgh. The gain in kinetic energy by a moving object is given by Ek is equals to half mv squared. If you find this lesson has helped you, visit my website for more video lessons. On my website, there are practice questions that have been carefully curated to help you reinforce your understanding. And remember to subscribe to my channel so that you can be alerted when I upload a new video.